Hello everyone, my name is Angeline Kang Xiaohan. I am a student from UTHM. So today let's find out about the 3D bioprinting. 3D bioprinting is a relatively new technology that in theory of human fabricate nearly any tissue or organ from scratch. The fundamental idea behind bioprinting is quite similar to that of ordinary 3D printing, which usually in plastic and prints one layer at a time instead of plastic. However, bioprinters use bioink, which is composed by cells suspended in a special gel known as a hydrogel. Some bioinks use a single type of cells, while others contain multiple types of cells that are used side by side, each with a different cell type. Bioprinting usually exists in three types, which I will introduce to you. Firstly, extraction-based bioprinting is one of the bioprinting which is similar to what most people will think of when they think of conventional 3D printer. It involves forcing continuous filaments of a material through a nozzle in a controlled manner to create a 3D structure. The material is bioink, which usually consists of cells and a hydrogel. The filaments are forced through an asshole by either pneumatic pressure, which comes from things like pistons or screws must be stabilized quickly, or else it will not retain its shape. The bioink can be stabilized in a number of ways, largely depending on the hydrogel that is being used. As an example, during printing, the bioink can be stabilized by spraying a mist with the cross-linking agent dissolved in it. By the way, cross-linking just means linking one polymer chain to another, and this is done to stabilize bioink. In contrast, droplet-based bioprinting deposits discrete volumes or droplets of bioink onto a surface. Droplet-based bioprinting method include laser bioprinting, microwave-based bioprinting, and laser-induced forward transfer bioprinting as with the exact. As with extraction-based bioprinting, the bioink must be quickly stabilized in order of the structure to retain its shape, and the exact manner in which this is accomplished depends on the hydrogel being used. Finally, in energy-based bioprinting, the focus energy source, often a laser, is used to selectively solidify or stabilize the bioink. Perhaps the most notable method of energy-based bioprinting is stereolithography, which a laser is employed to selectively harden a small amount of bioink, which contains a light-sensitive hydrogel. This substance lies on a platform that is then moved away from the laser by a small amount. If in doing so the platform is immersed into bioink, then a fresh coat of bioink will flow on top of the now hardened layer of bioink. Or if the platform has sidewalls, then a fresh layer of bioink can be coated separately. This process is repeated, eventually leaving you with a solid 3D structure once the liquid bioink is washed away. There are also have the set of procedures to perform bioprinting, and basically it involves three general steps, which are pre-bioprinting, bioprinting, and post-bioprinting. Pre-bioprinting, which requires to create a digital file for the printer to read. Today, these files are often based on CT and MRI scans. Research prepares cells and mix them with their bioink using a live cells imaging systems. Bioprinting. Research load the cell-laden bioink into a cartridge and choose one or multiple prints depending on the structure they are trying to build. Developing different types of tissues requires different types of cells, bioinks, and equipment. Last, post-bioprinting. Most structures are cross-linked to become fully stable. The contrast compositions help researchers determine what kind of cross-linking to use. Then the cell field constructs are placed inside and incubated for cultivations. Thank you.